Welcome everybody. We're here on our beautiful University of Arizona campus, and today we're having a conversation and a demo actually with Associate Professor of Mechanical and Biomedical Engineering, Kavan Hazeli. All right, so we are now inside the mechanical engineering building, and what we have here is the test bed where they develop technology that we are going to get a demo of for vulnerable populations. Professor Hazeli, care to explain this to us?
Sure, let's go.
What's all this?
So what we do, we are using the advancement in computer vision, machine learning, and haptic technology, which is a branch of robotics, to develop technologies for vulnerable population. And in this technology I'm presenting here, we are trying to help people who are losing their sight. Could be conditional like diabetes patients or people who are visually impaired. So they are the challenge for this population are two big things. One is object detection, what is around them, and then not to run into them, to trip over and have the fall injuries. So what you see here, the technology we are developing. So we have several modules that can help the visually impaired to navigate the space with the LiDAR camera. LiDAR camera is a type of the depth sense camera, so we can go around and scan the objects around. Once we detect them, we use the machine learning algorithm to explain to the user using the audio what are they, and with the haptic information we can communicate the location of the objects. So we have different prototype. One is the large one, is the first version of it, or if the users are preferred to have like a rest band, they can use this module. This module has 3 rings, and each rings represents 3 major direction in the room, and you place them around your rings. Oh, sorry, I have to go first this one. Just imagine if I put this one here, like my watch, and then I can close this one. And the way it works is, this one goes here, this one comes here, this one goes here, and this one here. So, and then this technology is connected to my depth sense camera, come from the iPhone camera or Android camera. And what it does, if I go to the unfamiliar environment, I probe the environment, and the data is received by the camera, converts to the information, which is what are they, and then also the location of the object is communicated with my rings. And as if we have a stationary object, you have a buzz. If objects comes towards you or getting away from you, the amplitude of the buzz adjusts with relative to the distance of the object. And that would.
So would you say this is fast enough if you walk into a room with other people? Does it turn the information into signals fast enough that you wouldn't walk into anybody?
Correct. So we understand sometimes is overwhelming to have the information all about all the objects. So for this technology we have 2 different modes. One is a travel mode. In travel mode, you don't necessarily provide the audio to the user about what are the environment, only tells you where there is an object coming up or there's a person over here. But if you are interested to know what are they, you can turn on the object recognition mode. Not only tells you where they are with the haptic, also give you the information about what are they. This is a tree, this is a dog, this is a chair, coffee table.
How many objects can it recognize?
Oh, so we have a huge database. So I cannot put a number into it, but we are talking about 100,000 of the objects.
100,000 of objects. And they were trained, I mean, this is like a machine learning approach.
Correct.
So you have different algorithms that learn to recognize the objects.
So we use the available data set and also we train with the unfamiliar objects. We go around the campus, look in the curve, students, logos, and something which is not in the publicly available database, we train our algorithm based on those. palm trees or citrus trees. We are in Arizona, and all of those information are building into the algorithm.
Can you tell us a little bit which algorithms?
So
I'm assuming it's deep learning.
Deep learning algorithm, correct. And also, in addition to this, so our algorithm should be trained and be more accurate because we're dealing with the human health. And if you are running into the objects which is not detected, then you have a problem with the technology. So what you're seeing here is a testbed environment. We are trying to mimic a living space for a person who, for example, has diabetes or has Parkinson, or for some reason they don't have the normal sight. So to do so, to train the algorithm to see how fast, as you said, the algorithm works, or how accurate it is, we are having a group of volunteers, we call them a stunt actor, and we try to mimic the situation to have clinical data. So to do so, we have this type of glasses. So these glasses are, you can partially become impaired or fully blind, and with those, we can see how people use this technology to get around and see the objects, see the object with our technology.
Can we have a look
and
at
detect
one
them.
of those?
Of course. So these are the glasses.
So these are just regular glasses?
Not they are available for training the
Is there any technology in the glasses?
No, not technology.
This is just to mimic the visual conditions that somebody else
to partially impair you, fully impair you.
Okay.
So a different degree of impairments can be introduced with this type of glasses.
So you can train all the algorithms with students who volunteer, or actors, or yourself, or friends and family.
Exactly. We are actively looking for stunt actors. So in addition to that, if you think, when you come to the elderly population, some of those people have diabetes and they lose their balance. And when you have diabetes also influence your sight and your vision. So what you see here is the aging suit. You can use the aging suit to mimic the imbalance for the people who are about to fall. So in those scenarios, our technology try to help to navigate the space and keep you away from sharp objects or things that could run into you, get the wound or injuries.
And I had a test of this before. It's really heavy. It's like heavier than your regular dumbbells. So it's going to slow you down. Can you tell us, like for example, for the rings and the visually impaired project, or the focus on visually impaired, how long have you been working on this?
So this technology, so there's some history here. The history is I was initially very interested in developing educational tools for visually impaired, but I realized there's a huge gap in the market. The gap in the market was we don't have a technology to detect the object and take you from point A to point B. So the regular GPS in your cell phone or Google Map give you the direction without telling you exactly what is on your way. So, and then when I realized I have all these volunteers comes into the lab and they don't have the chance to really navigate the space safely, I came up with this idea, what if I invent a technology not only has built-in GPS to take you from point A to point B, also to do that. So you asked me how long did it take? This technology exactly, we started 2 years ago.
It's pretty good. It's pretty fast, going from just the machine learning, the training on the video, to having the actual devices on
Actual device, correct.
That's awesome. And this is, we saw some students when we walked in here. This is a lot of student research, right?
Correct. So we have a combination of undergrad, grad, and postdoc working on this. So, and we have a group of students, they are working on the manufacturing and design, some group working on the electronics, other group on working on the algorithm development to do all this deep learning and neural networks for the system.
Yeah, well, this is great. Thank you very much for this demo. I hope we can come back soon, depending on how fast you develop it, for a follow-up maybe with some more demos. Thank you.
Thank you very much.